So we are trying to look at this particular question on capital budgeting. Okay, the management of BMX Limited is considering an investment project. The following data are provided. Cost of the plant is 27 million, salvage value is 0, useful life is 3 years, expected profits or loss, okay, for the years as follows. BMX uses the straight line method of depreciation for all fixed assets. The estimated cost of capital is 10%. Now we have to calculate what? Calculate the accounting rate of return. So let's go ahead and do that and see what answer we'll get. Accounting rate of return. You just need to know the formula as well. These are appraisal techniques that you're being asked for, or capital budgeting techniques. Well, it's all about the formulas for these, and then you'll see how you can use the information to answer. Okay, so take note of the cost. We'll need the costs. The cost is what we would recognize as the initial investment, or what they would call initial outlay. Okay, then when you're looking at ARR, it's all about the profits or income. Profit, or yeah, I would say net income, which is as good as profit. Just understand that. So we'll need all those profit figures. All right, let me go to the next screen and show you how you calculate ARR. So ARR is equal to, of course, your net income or stroke profit over, and sorry, supposed to be average net income or profit over initial investment. There are two, but I would rather focus on this one. It's the best measure of ARR. There are two formulas, but just go for this one, initial investment. So let's substitute what we know. Average profits. Well, we had a profit in year 1 of 7.5. I'm just debasing the last zeros. The next year had, what profits? It was at it was in brackets, meaning this is the negative 5 to 50. Then the other one was 6, 7, 50. Now, since it's average, how many of these profits are listed? There are 3, right? So to get an average, just divide by 3. Because there are, again, another thing to look at is again that they are coming in 3 years and you want an average, so just get 3. Okay, if there are 2 years, it will just be 2 there for the average over initial investment, which is 27 million. Okay, so even when you're subtracting there on top, but since I'm debasing, let me just keep out the last 3 zeros, because even on top I was removing the last 3 zeros. When you get to divide this, I'm sure on top you should get 9, sorry, you should get 3 on top, get 3 million number of debases, so get about 3,000 there. Then you're dividing by 27, right? What ARR are you most likely going to land on? Okay, so I just debased some the last 3 zeros I forgot in the denominator there. Okay, I was putting the entire 27 million, but since I'm debasing, I'll just have to be removing the last 3 zeros since I already started with that on my numerator. Therefore, you'll find that to give you 0.11 as your accounting rate of return, which can be changed to a percentage if you want, or 11%. So just can use that, the decimal percentage will be marked. That's how you answer the first part. Intern accounting rate of return. The next question, if you look at 2, it's asking for the payback period. Well, when you're looking at payback period, what things do we need from this question that will help us calculate payback period? Well, it's first of all the cash flow that has to be determined. It's the first thing you need to know. When you're looking at payback period, we deal with cash flows. So how do you even find a cash flow from this information? Which one is the cash flow? Well, you have profits only in the question, and the cash flow, of course, it's some form of benefit, of course, that we get from where our profits that we realize at the end of the period. Now take note of this. Profit in a period is not necessarily called cash flow. Why? It contains a non-cash item in it, which we call depreciation. Let's take note of that. Yeah, so profit, yes, you would say, okay, why wouldn't this be cash? It's not cash because of that one component that sits in that figure, depreciation. It was initially subtracted to get profit. If you remember your your financial statement preparations, even from your financial accounting. But the rules are that since it was subtracted initially as an expense, add it back to make this profit figure a cash flow. And that's what we're going to do. So what is depreciation? Well, they've said that it's assuming the straight line method. I'm assuming this method should not be foreign to someone who's just from taking financial accounting. Okay, so we go to straight line method. We need the cost price, we need the scrap or salvage value, we need the number of years, which are 3. So let's go convert. So we said cost price, 27 million. This time I've written the whole figure, minus salvage, or scrap, 0, over number of years, 3. Therefore, what is depreciation? 9 million. We need depreciation. As we said, we'll be adding it back in all those entire profits that are coming in those 3 periods. Now, in a straight line method, is our dip going to be fixed all the years? It's actually going to be fixed. Remember, straight line method, the dip charge is fixed every year. You'll be seeing the same charge every year. Therefore, start converting each and every profit to a cash flow by adding back dip. That's just what you should know. We had in year 1, we had the cash flow of 7.5 million. Add back dip is what I'm meaning. So every profit figure that you have, profit or loss figure, it's supposed to be just add back dip, because depreciation was initially in that total according to how we prepare financial statements. So there you add, this is 16.5 as the cash flow figure in year 1. Next, year 2. Year 2 had that negative 5 to 50 million there. Then you get to add dip of 9 again, since it's fixed each year. Where do we land? 3,750 cash flow for year 2, because we're obeying the negative sign there. 3, we had 6,750 plus 9 million. What do we get for this particular one? 5,750. So once you get all your cash flows, now you can compute the payback period, because the payback period deals with cash flows. So you should have a column for year, cash flow, and accumulated cash flow. This really helps in the payback period, because the payback period is just a time period when you actually receive exactly what you invested or the actual cost that you incurred. So year 1, start writing the cash flows. We found 16.5. Again, I'm just looking at my space. It was supposed to be 16,500,000, but I'm just basing my last 3 zeros. And then, meaning the accumulated, what do you put? It will be at that same figure, 16.5, right? Because that's just like the first receipt that you have. Year 2, 3,750. That was the next cash flow, right? Again, this was million. I'm just removing the last 3 zeros. Then, what does accumulated mean? Meaning the figures will keep on adding up in that last column. So you're at 16.5. You've received another cash flow of 3,750. What do you land at this point? This will be 22.50. Next, year 3 had another cash flow of 15,750. This cash flow of 15,750, if you look at it, if we add up to this 20, we're going to land at somewhere like a 30 water. In fact, 30 something. Now, what is our focus here? We want to get back what we initially invested, and so far in 2 years, it's showing us that we are on 20 million something, right? Now, the thing is that we want to get exactly what we invested, which is 27 million. How much is left from 20 to 27? That's the question you should ask yourself. Because the next cash flow is showing us that we will exceed, and we don't want to exceed. That's the problem in the payback period. It just wants exactly what you invested, nothing more. So you'll find that there's a difference of 6,750. But the thing is that this has to be shown that it's being taken as a fraction of what? As a fraction of the next cash flow, 5,750. Why are we taking a fraction rather than just putting the actual difference? Because this is a period we are estimating. So when you're estimating a period, the best is represent it as a fraction. because you know what, you are supposed to get the 15,750, all of it in the next year that was coming, year 3. Now we only needed a 6,750, okay, which is probably just will come within a certain number of months period, but we wanted to know that same period. Therefore, the best thing is express that amount needed over the amount where it's coming from, and that's how you estimate the period. So when it's about payback period, now how do you record the answer? So far it has shown us that, okay, when we're on 2 years, right, we reached that 20,000. So we get to realize that's 2 years and say, okay, we have 2 years so far, which gave us that 20,250, right? Plus there was a remainder 6,750, which we did not yet know exactly which time period it's dropping in, but that's why we said take it as a fraction of the figure that we got it from, which was the next cash flow of 15. That therefore you would find that you even get 2 point, okay, here to give you 0. What's in this fraction, okay, somewhat to 0.43 or rounded off. Yeah, therefore it even gives you this answer as the payback, 2.43 years. Okay, next appraisal technique. The next technique is asking for the net present value. Well, the net present value is a measure that requires what? Cash flows as well. Just remember that. So most of the time when looking at net present value, our cash flow should be after tax. That's something just to remember as well. Even though we did not also talk about that in the payback period, but all our cash flow should be after tax. So you'll notice that our question is rather silent on tax. If we do scroll above, there's nothing about tax. So if there was tax, we would have just done some quick adjustments, and yeah, so since this question doesn't have tax, we would not go through that route of starting to stress and find that. Yeah, but just remember that usually our cash flows are made after tax. But if there's no tax, then we'll assume that these cash flows that we have converted by adding back depreciation, they have just been converted to that same particular after tax cash flow. Now we got to net present value. We need what? Cash flows and the initial investment. That's all we need. And what else? Well, when they've said present, meaning we'll be taking these cash flows to the present. Therefore, we need the rate. Which rate? The cost of capital will be your rate. Remember, the cost of capital you learned in the previous topic. This is a certain rate that is estimated on maybe any project that's being taken on. So that's why they get to use that rate to discount there. So we'll use 10%. So when you're looking at the net present value, the best is create another table. These things just help to find the present value of all your cash flows, and thereafter at least life is made easier from there. So year 1, year 2, and year 3. We already converted our cash flows as of year 1. If you just rewind our video, we found 16 here. Here we got what? 3,750. The last one we got 5,715. Sorry, 750. Then now we start discounting. Year 1's it's 10. That's 10%, right? Go to year 1. In which table? The PVIF table. These are not annuities. Do not go to the one with A. That's just a guide. An annuity is a fixed amount each year. Now these are not fixed each year. So therefore that's the table we're using. And we said go and use what's this? 10% year 1, because it's in year 1 and you want to find the rate, which is like 9091. Year 2's discount rate will be what? 2's discount rate is 0.8264. The third one, year 3, that will be that. Just check your tables again. It will give you 0.7513. Then you start converting this to the present each. So for the first one, you will notice that it should give you 15,000.15. The next one, okay, that's 3,750. By the way, I've just debased my figure. So if you've debased, follow that same rule. If you are using the entire 16 million, you can also write it, no problem. Like when you just debase, just of course indicate to your lecturer that you debase by putting some zeros on top there. I'll show you very soon. So now you can do that. I'm getting 3099 on this one. 3099. Next, so the last cash flow, 15750 times 0.7513. 15750 times that, 11,832.975. Then you add everything. That's how you convert present value of your cash flows, because the formula for NPV, as I'll even show you soon, it requires you to find the present value of the cash flows, then you get to subtract that from the initial investment. That's what you should know. So it means it has given me this. That's the total present value of the cash flow. So you get to add up for everything. Don't just treat them separately. After you've done that, converted each to the present, add up, because we need the present value of the cash flows, as the formula will show you. Okay, so the present value of cash flows, okay, this is the formula for NPV, which we have found, minus I, which is the initial investment or outlay. Present value of cash flows was 29,932.125. Sorry, 0.125 minus, what was the initial investment? It was 27 million, but me, since I'm debasing, as I've said, I'll follow with my format of removing the last 3 zeros even when I'm putting in this initial investment as well. Therefore, what do I get? Positive or a negative figure? Well, I'm getting positive 2932.125 kwacha. So, well, this is my NPV. That's how you calculate net present value. So NPV usually just a trick. If it comes out negative, usually they say do not accept such a project, because that's showing that it will not be profitable. If it comes out positive, just say we accept a project because it will be profitable. Yeah, the last technique is the internal rate of return. That's what they said on number 4. Well, IRR, what you just know is that this is a rate at which your net present value is equal to 0. We want to find that rate that will equate NPV to 0. Let me show you this guide on how we pick rates. Okay, well, if our cash flows are not fixed, this is something to remember. If our cash flows are not fixed, go with a trial and error technique, and I'll demonstrate how you do that. But if our cash flows were fixed, it would have been easier. We would have just gone to the net present value formula, okay, and just said, of course, it's equal to the PV of cash flows, whatever, minus I. And then, you know, since the cash flows are fixed, you just pick one of them, since you know that it's representing everything. Like maybe let's say 20,000 was the cash flow, then you would always have to multiply it by 10 discount rate, right, to bring it to the present, and then you subtract I. Then at the end of the day, just trying to make this the subject, the PVIF, and it would be easy to go and locate the rates. That's the advantage of fixed cash flows. Now, this is not fixed in our case. They are changing each year. Well, we use a trial and error technique, okay, where you pick 2 rates. You pick 2 rates, but you have to be strategic about how you pick. Don't just pick anyhow. The best way is this. Most of the time when we're picking our rates, you can even tell from the figure that came out as your net present value, right? According to your cost of capital at what? At 10%, we had a net present value of about 292, if you remember, 2932. We're looking for, okay, our target is an NPV that would be 0. And this is the trick. If your cost of capital here gave you a net present value which was like slowly drawing towards 0, right? Meaning pick a rate higher than it, for sure you will achieve your targets. That's how it is. When you are trying to end up to 0, right? You're finding the rate that will land you at 0. When you are using the trial and error rates, the 2 of them, first of all, the first attempt to pick is look at the cost of capital, that net present value it's giving, and then from there it will guide you. So like you can look at the net present value of the cost of capital 10%. It's okay, it's 2,000 something, but if you pick a rate higher than it, for sure you'll be drawing towards 0. So that's the trick behind that. Usually if you pick a rate above cost of capital, you'll be heading towards your 0. So let's find 2 rates which are above 10, and then those are the ones we would get to use as our trial and error. So you're trying out 2 rates. Take note of this. And we said the rates that you're trying out will be picked above cost of capital because you're heading towards a 0. And the only way you can head above towards 0 is by picking a rate that will be higher than the cost of capital. That's just a trick I can show you. Then those, and you're picking 2, not 1. So one of the rates you pick, me in my case, I'm trying out 15% and I'm trying out 17. So even the two rates that you're picking, they should not be far apart. They say the reasonable distance is just at least what's this? That's 2% away from each other, or 3 as just the worst case scenario. Don't go too far. Yeah, usually 2 to 4 is the range, but we mostly advise at least 2. It minimizes that distance. So when you're picking these two rates, one of them should give you maybe a positive NPV. We're just trying out this. And again, another one should also give you what? A negative NPV. That's just your target. So even when you're picking your two rates, be careful to this thing I've stated below. One of the rates should give you a positive NPV, like for example, if you pick 15, right? You go and test it out in the net present value formula by discounting your cash flows and see what net present value you get, if it's positive or negative. Try another rate, test it out in the net present value formula, see if it gives you a negative NPV. Then these are what we are looking for to work with, okay, when calculating IRR. So take note of that. So those two rates again, they shouldn't be far apart. Me in my case, I've chosen 15 and 17. Okay, so one of them, this is how I'll show you a screen of how I've managed to do this and tested them out, and I'll show you the answers that they are giving, and from there we can proceed to find IRR. So this is what I was talking about. You pick a rate, you go and try it out in the net present value calculation. How do you find net present value? Present value of the cash flows, which are given in the question, the same cash flows we found. Find the present value of those cash flows, then subtract from initial investment. That's how you find net present value. My first net present value, which I'm calling NPV1, because this is the first rate I'm trying. That's why I'm calling this NPV1, and you will see why I'm even labeling these things as NPV1. This is very important. And by the way, the first rate that you try, we call it R1 or rate 1. Just take note of that. So in this case, rate 1 will be 15%. And then our first NPV that we get is what we would call NPV1. So me, I've gotten a positive NPV, right, when I tried 15%. But you can see that I'm drawing towards 0. Because at cost of capital of 10%, there was what? 2000 what? Now, look at the rate I've picked. I'm slowly heading towards 0. Pick another rate. I tried 17, as I said, the two which I picked. 17 brought me to a negative net present value. At least that's my target, a positive and a negative. And as I said, the percentages shouldn't be far apart, and most of the advisable distance could be just 2. So they can even advise you that one. Then I tried out this one. I just didn't label it. It's supposed to be called NPV2. Then from here, the NPV1, NPV2, having recognized them, and then the second rate that you try will be rate 2. Just take note of that. Then I'll show you a formula where you just substitute all these, and the IRR will be determined like there and then. So we just get to use this formula. IRR is equal to, so now I'll use one of them. There are many. I'll go for this one in this video. Okay, NPV1 times R2, that's rate 2, minus NPV2 times rate 1. Okay, over NPV1 minus NPV2. These are the formulas we work with. This one, it will give you the direct IRR you're looking for. Then just substitute. NPV1, we found it. I even labeled it in the earlier screen I shared. Although NPV2, I didn't label it, but just know that NPV1 is as a result of the first rate that you try. NPV2 is as a result of the second rate that you try, which was 17. Yeah, let's just substitute. Remember the formula, copy it down, because I want to erase this on the screen and start substituting. Okay, so our NPV1 was 539.03 multiplied by rate 2. Rate 2 is what? 17%. That was the second rate. That's why we're calling it rate 2. Change it to decimal, 0.17 minus the next one is what? NPV2. NPV2 was what? It was a negative 676. So I'm putting it in some brackets so to differentiate that sign which is outside there. Negative 676, sorry, 0.23. Let me complete that. Close those brackets, and then we are multiplying by rate number 1, rate 1, which is 15% as a decimal as well. The whole thing over NPV1 539.03 plus NPV2. In fact, it's minus, but you know, it's like minus up. That's why I wanted to write plus, but let me just show everything step by step so that people are following through. Then just go and punch this on the calculator. What rate do you get? I'm getting this answer when I punch everything 0.15889. Okay, I'll just end there. I've rounded off to like 4, just 4 decimal places is okay. That's the maximum you can put. Which we're looking for a percentage. A rate is usually a percentage. Then you can just say this means 15.89. So this rate that you have found, when you go and test it out in the net present value formula, this same specific, don't even round it off, no, this same specific 15.89%. I know it's not on the interest factor table, but you can use that 140 way of putting in a rate. Okay, when it's not on your table, I'll show you. But you can go and test out this rate in the net present value formula. You should get 0, or at least something that can be rounded off to 0 as the net present value. That you have found IRR. So we always test just to be sure, but this is how you calculate IRR using trial and error basis. Just know that. So of course, when you're picking the rates, pick 2 rates in such a way that, okay, even though the 2 rates I've picked, they are not far from 0. Okay, the 2 rates that you should pick, they should not be too far from 0. So you're trying out to one of them should give a positive NPV, one of them negative, because the whole essence is to trap that 0 which is in between positive and negative numbers. That's why you pick a positive and negative NPV. That's the reasoning behind all this. You even tell the, of course, is it your lecture in your exam? Okay, my RRR is 15.89%. That's all. That's how you have to answer this particular question on capital budgeting techniques. So like I was saying, that imagine that it's this percentage you want located on your interest factor table, right? So you just go and use this formula from mathematical analysis, okay, where you just say 1 plus r the power. It's now since present you'll be saying negative n for all your cash flows until you find them to the present. Yeah, that's how you would be substituting, and this is how you would handle such. But basically IRR, that's the technique if it's trial and error. So I got to try out this rate. I was not getting an exact 0. I was getting, I think like 140 positive. So now the thing is that you're aiming for a rate that gives you 0. So as I said, okay, the ranges that we choose in, they shouldn't be that very far apart. Like I said, 2 or maximum of 4. So the way we've used the distance of 2, we're getting something that's what not 0. Try maybe a distance of 4, maybe 15. Pick these 2 rates, 15 and 19, and just see what IRR you will land with. Definitely this one will give you a negative NPV, and this one we already know it's given as a positive. Then of course that's the criteria we work with. We've put into that formula again. Me, when I did that with 19 again, okay, I'm getting an IRR rate of 0.1628, just rounding off to 4 decimal places. If you try out this rate, I believe you stand now a better chance. But which still stands in that drawer, the one which we studied as, I'm sure the IRR might be just between these, these 2 rates, 15 and 17, because it's a rate at which NPV is what? Is 0. This one give us a positive figure, positive something. This one, if you notice, our 17 and that one give us negative something, right? Then we are looking for a positive figure, you're looking for 0, which is, it's apparently going to be in between 15 and 17, definitely. So anyway, we just increase the distance just in order to achieve that 0. So if your distance of 2% fails, try the distance of 4 at least, and see if they shouldn't go over 4. You'll be now exceeding too much. Yeah, so just at least that. We said we're going with 15 and 17, so therefore after 15 and 19, sorry, it gives us, I think, this as our IRR. That's how we estimate it. So it's just the issue of trying and error, which might look difficult, but please, this is the technique that we use. Just grasp it like that.